Hi guys. Well, welcome to our next video homework. We got two primary goals of things I want you to be able to do when we get back in class together. The first of those is know the different contraction classifications. So we're going to talk about contraction types as concentric, eccentric, or isometric. The second is I want you to know the three basic planes of motion. So we'll introduce you to those and be able to describe what are the motions that occur within each of those planes. The last thing that we are going to cover today, but I'm not going to ask you to be accountable to, I just want you to understand it, or maybe better to say, I want you to recognize the information and be exposed to the information is the concept of axis of rotation. So with every plane of motion, we have to have an axis of rotation, but we'll get to that in a little bit. And I just want to let you know for our intro class, I just want you to know that there is such a thing as an axis of rotation, and that there is one that's unique to each of the planes of motion, and that every motion that we do works around an axis. But I'm not going to ask you to repeat the vocabulary or to be analyzing a motion using the axis of rotation information. If you know the planes of motion and you know the name of the different type of contraction that's taking place, you're good to go. So let's take a look at what we are dealing with today. Before jumping into any of those, though, let me introduce you to three ways of describing which muscles are responsible for individual motions. So, when we look at the terms agonist, antagonist, and synergist, these may be terms that you have some familiarity with, and they may be absolutely brand new. Agonist just means it's the muscle or muscle group that's the primary response has primary responsibility for the motion that you are talking about. So in this illustration, you see a person doing a bicep curl. You can tell that because the arrow of the weight movement is moving from an extended towards a flexed position at the elbow. So if we are doing elbow flexion, we know that, or if we're doing a bicep curl, we know that the biceps brachii is the primary muscle that's responsible for helping with that motion. You may also know that the brachialis is a nearly equal contributor to that. And if you don't know that yet, well, you're going to learn about the brachialis in A and P. But you can see from this illustration as they're color coded here, these blue muscles are the ones that are really the ones that are most responsible for creating the motion that we're talking about. They're the prime movers. And in this case, we're talking about a bicep curl or elbow flexion. So if I'm flexing my elbow, there has to be some muscle group that can create the opposite motion. Because we know I'm not just going to go from a flexed elbow to staying with a flexed elbow for the rest of my life. I have to be able to extend that elbow in some way. So the muscle that does, or muscle group that does the opposing action, the opposite action is referred to as the antagonist. So it's that muscle group that's going to have to relax really well for our agonist muscle group to be able to perform the action smoothly that we want to. So we've got an agonist, we've got an antagonist, and then the last muscle group or the last nomenclature we have there is synergist. It just means an assisting muscle. So because of its origins and insertions, with the insertion point that's buried here in the illustration, but it's distal to the elbow, it means that if these two ends, if this end and this end are actually going to shorten or come closer together, that the elbow is going to flex. So it turns out the brachioradialis is another muscle that actually helps you to when you are doing bicep curls. Now, it's not the prime mover, obviously. We don't go to the gym and pick up some free weights and say, I am doing my bicep curls to try and really work on my brachioradialis today. But the brachioradialis is contracting and is contributing to that motion. So, agonist is the primary movers, antagonist is the ones that have to relax and that do the opposing motion or opposite motion, and synergists are the ones that can provide a little bit of assistance to that motion. So, let's get into what I really was hoping to spend a little more time on for you today, and I hope that you spend a little more time just making sure you're making slides or studying in some way. Actually, these first few terms are probably the ones that are most familiar to you out of everything that shows up within the video today. we're going to talk about contraction types. So contraction just means whenever the two ends of a muscle, the two origin insertion or the two tendinous ends are coming closer together, that's what we refer to as a contraction, when those two ends are being drawn together. So we know some basics around this about the thick and the thin filaments, the actin and the myosin, and creating cross bridges and pulling those fibers or those microfilaments towards each other. So the Z line, pardon me, of each sarcomere gets closer and closer together. And when that happens hundreds and hundreds of thousands of times with an individual muscle, the entire muscle is going to shorten. But we also know that the central nervous system doesn't have to recruit muscles at 100%. It can recruit those muscles at 90% or 60% or 30%. So we can create tension. We can create tension within a muscle, but sometimes the tension that we want is not to the extent that it's actually going to overcome the resistance. So let's give some names to those three different types of contractions. These again are things I think are probably more familiar to you. So let me move my video piece here so you can see the illustration just a little bit better. The concentric contraction just means that it's a shortening contraction, that the muscle is developing enough tension within itself that the two ends of the muscle are in fact going to get closer and closer and closer together. You are going to see a shortening or a concentric contraction. In this illustration, you see somebody here that is providing an external resistance against adduction. You see the lats here that are working to bring the shoulder into adduction. And if that is moving, if the individual here is generating enough force that even though it's being resisted against, that the shoulder comes closer and closer and closer towards adduction, that would be a concentric contraction. Can you imagine? Can you think for yourself what would be the opposite? So if this was the agonist, the primary mover to create this adduction, what in the heck would be the muscle group that would be the antagonist, the ones that oppose that or do the opposite of that? Well, this illustration will not only demonstrate that for you, but it will also talk about another type of contraction type. So concentric means shortening. Eccentric means it's going to be lengthening. So the muscle is still producing tension. It's still being recruited by the central nervous system. But now, instead of bringing the two ends closer together, even though that muscle is creating tension, the two ends of the muscle are actually getting further and further and further away from each other. Now, that can be a very, very slow piece, or it can be a little bit faster. So we can oftentimes use eccentric contractions to slow down a joint movement. Now, I asked you in the previous slide if the lats are working as an agonist to try and bring that shoulder down into adduction. What would be working as an antagonist? Well, it turns out your deltoids are a primary antagonist to that. So you see those deltoids illustrated up here. So now let's talk about if this hand is coming down. Let's say you've gotten to the top of your jumping jacks, you're bringing those arms down, but you don't want them to slam against the side of your body. You want to slow down their motion once you start bringing them down. What muscle is going to do that? Well, that's going to be your deltoids. But if they're going to be contracting but trying to slow that joint down, it's still allowed to move. The deltoids are still going to be lengthening overall, but generating force. That's an eccentric contraction. So concentric means shortening. Eccentric means lengthening, and it's very often that we use an eccentric contraction to slow down a joint or to act as a brake. The third of our terms that we're going to have is isometric. So if we've had one that shortens, one that lengthens, then isometric is going to be the one that defines when a muscle is creating tension, but it's neither lengthening nor shortening. It's staying equal length. You'll find some of this vocabulary to be helpful as you continue on. Iso, this prefix here that you're seeing up at the top, means same as. And metric is a measurement of length, as you know. So these are going to be the same length. It's going to be a static contraction. meaning the muscle doesn't change its length, same length for the muscle. So we can develop a lot of tension in the muscle without any really appreciable change in length. Think about doing wall sits, and as your quads are just burning and burning, but nothing's really changing in length. That's a very common example of an isometric contraction. We will also use isometric contractions, or oftentimes, if we're trying to stabilize or balance, we may have an agonist and an antagonist that are contracting at equal rates. So you can sit there and for yourself, you know that you can contract and tighten muscles within your body without actually making your joints or without making your body move. So you're doing numerous isometric muscle contractions where you're firing both an agonist and an antagonist at equal rates. So you're developing tension in them, but because they're working directly against each other, you're not actually seeing any motion. Okay. Um, your wall sits were a common one. Another one that I could give you for a common example, if you try to pick up anything that's really way heavier than you can actually lift, you're developing lots and lots of tension, but you're not actually changing, you're not actually shortening that muscle, and it's not lengthening. So if there's a heavy, heavy weight that's on the ground that you're trying to pick up, it's not getting further away from you, but it's not getting closer to you either. We're developing lots of tension in the muscle, but nothing's really moving. The joint is not really moving, and the length of the muscle is not really moving. So that's considered an isometric contraction. So you got your concentric contraction, you have your eccentric contraction, you have your isometric contraction. We've also talked about the idea of an agonist, an antagonist, and synergist. Let's get on to what's probably the most challenging, or maybe the least familiar is a better way to say it. The next thing we're going to talk about is the plane of motion. So this is something that I do want you to be responsible for. This is something you should be working to memorize. Now, your plane of motion is just this imaginary two-dimensional surface which a body, limb, or body segment is going to be moved through. The part that's going to be a little more challenging is we are going to introduce you to the idea that every plane revolves around an axis. So we are going to talk about axis of rotation. And every plane of motion has a 90-degree relationship between the plane of motion and its axis. But let's get to that in a little bit further, or a little bit later. Let's talk about those planes of motion first. So we have an imaginary two-dimensional surface through which a limb or a body segment is going to move. I'm going to be using this, let's see, try and make sure it shows up on the video, this sheet of paper as that imaginary two-dimensional source. So you can get a good reference to it as a two-dimensional source. You've looked at two-dimensional things in math over and over again. This is two-dimensional. Essentially, it's got an x-axis and a y-axis, and for all intents and purposes, it doesn't really have any z-axis. So here's a two-dimensional surface. Now we're going to talk about motions occurring on a plane of motion, or movements acting on a plane of motion. We have three basic planes of motion. When we look at our anatomical position, we have these three reference planes. Now, here's part of why this can become confusing. Multiple, or each plane can have multiple different names. So I'll tell you the ones that I preferentially use, partly because it's the way I was taught, and partly because they're the ones I might have switched sometimes to one that just makes more sense for my own visualization. So I'll tell you the ones that I'm more likely to use within class, but we're going to introduce you to each of the different names so that you can recognize if you're doing reading in another area, or if in A&P or in another class they're using another of the appropriate names for the same plane, that you're aware that that's not the misspeaking on their half. So we're going to introduce you to the anterior posterior, or what I refer to as the sagittal plane. We'll talk about the lateral, or what I refer to as the frontal plane. And then there's a third plane called the transverse or the horizontal. And each one of these, again, is referenced to the anatomical position. So we've already covered what the anatomical position is. Let's start off with the sagittal plane. It could also be called the anterior posterior plane, but it's going to be dividing the body into two equal segments. So I don't think I'm going to use my sheet of paper right now. Instead, if you can imagine that gold sheet of paper, which I will hold up just so you have it again, as this is the reference point that I'm using because it's going to become helpful, hopefully, in just a little bit when we talk about axis of rotation. Here's that two-dimensional plane, imaginary two-dimensional plane. It's cutting the body into two equal halves, a right half and a left half. Now I can move this plane from the exact midline of the body more distally towards either side, and it's still that same plane, but it's going to divide the body into symmetrical halves. So an example of a motion that's going to occur within the sagittal plane would be a sit-up. This guy is supposed to be moving like crazy, but he's not moving like crazy. I'm going to try and go back here just a second. Sorry, I thought I was going to make the guy do his sit-up. So if you can imagine a person, I'm going to bob my head just a little bit, but if you can imagine a person or yourself just doing a sit-up over and over and over and over again, you can see that as they're flexing and extending in the abdominal area, that they're essentially tracing a pattern that follows right along this plane of motion. So if you think about a photo where the exposure's been left on for a really long time, so you see motion instead of just it freezing motion. So you see it tracing motion or this ghost of motion. You would see that ghost of motion would trace out along this plane. It was as if we were drawing on that sheet of paper. I hope that makes sense to you. So if we think about things that are going to be taking place within the sagittal plane, flexion and extension motions are going to be the best examples of things that are taking place within the sagittal plane. Okay, now let's look at the frontal or the coronal plane as the two ways that I typically talk about it. They can also be referred to as the lateral plane. So the frontal plane, that makes sense to me to call it that way because it's going to divide the body into a front and into a back. Front and a back. It also makes sense to me to call it the coronal plane because if you trace this out across the person's head, it's like as if it would be as if they have this big crown that's going right over the top of their head. So those are the two that I use the most frequently. Lateral is also incredibly accurate and appropriate as well. So it's going to divide the body into a front and a half. And again, this was supposed to be a little moving guy, but if you can imagine this person doing jumping jacks, then you can picture them tracing as if their hands and their legs are tracing out motion that's along this plane. So if jumping jacks are a good example of somebody doing activity that's in the frontal plane, what is the name of that kind of motion that's really common or that's going to be in the frontal plane? Yeah, adduction and abduction is probably what you already said, and you'd be right on. Okay, so let's move on to the last plane of motion. It's seeming really easy right now, right? But they just get confusing a little bit because there are multiple names for each plane, and we oftentimes don't do one motion that's um, with the body moving in three dimensions. We often have to describe an action as taking place in multiple planes. But let's continue on. So now is a transverse plane, or some people will refer to it as a horizontal plane. Horizontal makes sense. It's like the horizon line, but I was taught the transverse plane, so that's what sticks in my mind and comes out of my mouth most of the time. So the transverse plane is clearly going to divide the body into an upper portion and a lower portion. And it's rotation that's going to happen around these planes. So if we could imagine this brown illustrative plane dropping down to even with his hands, you can imagine that his hands, oh, we can't see that, his hands would be creating or tracing motion along that transverse planes. So rotation around the transverse plane, adduction and abduction around the coronal or frontal plane, and around the sagittal plane or on the sagittal plane is our flexion and extension exercises. Okay, so that's the big stuff I wanted you to be prepared for next class. Cover that multiple times. Try to make sure that you got that locked down, that you know those names, that you're able to, if I ask you, okay, this individual is doing lunges, what motion is happening at the knees and at the hips and at the ankles? Now, can you tell me what plane of motion that's taking place in? Can you tell me if it's a concentric or an eccentric contraction based off of whether I tell you a muscle group? And what's going to be the muscle group that's working as the agonist or antagonist during those things? Those are the kinds of things we're going to be doing next class. I'm going to bring us to this last piece, which is informational, not something that needs to be memorized or studied, but I do want you to watch it. Okay, so with every plane of motion that we had, remember I utilized this piece here. If it'll just show up, how do I get it to show up? Stop fading out. We use this sheet of paper as an example with its x-axis and its y-axis, but no z-axis. So this is representative of our planes of motion. Every plane of motion needs to have an axis of rotation. So for anything to be able to move along this plane, there also has to be, and I'm not so sure that the video is going to do the best job of showing that, but there also has to be something for it to rotate around that's at exactly a 90-degree orientation to that. So now I can spin this paper, I can create motion, whether it's flexion and extension along that sagittal plane, or if I move it in this orientation to me, and now I've got a frontal plane, and I'm looking at adduction and abduction, there's an axis of rotation. And if I was looking at that horizontal or transverse plane, so it was cutting me in half from a top to a bottom, then I can create rotation around that plane. But it always has to be around an axis. So this paper clip that I'm using here, and that you're going to be experimenting or just practicing with when it comes class time, represents the axis of rotation. Okay, so here's why that becomes confusing. First, you got to figure out what the motion is, then you got to figure out what the plane is, and then you got to figure out what the axis is. That doesn't sound overwhelming. The challenge is, unfortunately, that oftentimes the axis of rotation, the name for the axis is identical to the name for the plane, and people can just get hung up on that. I can still get hung up on that. So it's not, don't be overwhelmed or confused. Don't be frustrated by that. But it is a piece of information I want you to be aware of. So if we're looking at the axes of rotation, we'll talk about the frontal axis, which could also be referred to as the coronal or the lateral axis. And it has essentially the same orientation as the frontal plane of motion. So it runs from side to side at a right angle to the sagittal plane. So here again, I'm going to take the piece of paper to create my sagittal plane. It's going to divide me in half from right to left. That means that this axis then is going to be oriented in this space. So you can see now that this axis is running from right to left, which was also the name of what we referred to as the frontal. In this case, since we're talking about axis, we're going to refer to that as a frontal axis. If it had instead been a plane of motion we were talking about that that separated us from front to back, it was the frontal plane. So again, these axes of rotation now mean that these are going to be the axis of rotation for flexion and extension movements that take place within the sagittal plane. How'd that go, right? Like it's not super complicated, but it just is confusing. And it's okay for you to be a little bit confused. Here's the next one. The next axis that we're going to talk about is the sagittal or the anterior posterior axis. It has the same basic orientation as the sagittal plane, meaning that it's going to sort of help to identify or move from front to back. But it's at a right angle to the frontal plane. So my sheet of paper here is now going to be representing the frontal plane. That means that the sagittal axis would have to be at a 90-degree angle to it. And we already talked about, and it was much less confusing before we added an axis of rotation. We talked about that on that frontal plane that abduction and adduction movements take place. So it's around the sagittal axis that those movements are originating from. And then the last one is referred to as the long or the vertical axis. This is different from anything we've talked about so far because it's going to go through the transverse plane, or it's going to become the axis point for any motion within the transverse plane. So anything that has internal or external rotation is derived from the long or the vertical axis, and that motion is taking place on the transverse or the horizontal plane. So that brings us to the end. Again, those axes are not something that you have to have memorized for class. The other pieces are, you should be able to tell me if something is an antagonist and an agonist and antagonist or a synergist. You should be able to tell me when a muscle group is acting as a concentric contraction, an eccentric contraction, or an isometric contraction. Then you should be able to tell me what the plane of motion is that flexion is taking place on, extension is taking place on, adduction, abduction, and rotation motions are taking place on. And that is it. I hope you have a great rest of the day, and I will see you later.